Solving. Yesterday, I read Spaghetti and Meatballs for All. Hopefully, you will listen to the read aloud because we're going to use that as for our story. We're going to use that story as our lesson today. So, hopefully, you listen to it. All right. In the story that I read, the family must create a seating arrangement for a party they're hosting. What I would like to do is extend this book into a perimeter lesson. I would like you to come up with a seating arrangement for a party of your own. All right. You might want to grab your journal right now or a notebook. Math journal is a great thing to write in. You're going to pretend that you are planning a party for 18 people and you have 6 square tables to use. You don't have to use them all, but you have 6 that you can use. Each table seats 4 people, 1 on each side. You may put some tables together or keep them separate. Draw a picture of your table arrangement. There should be no empty seats. And when you're done, you're going to find the perimeter of your design of the design plan using the side of the square as 1 unit. All right. You might want to grab some manipulatives, like some square cereal or some crackers or some blocks or some Legos, maybe even some Cheez-Its, and use these to move around and make different combinations of tables. And count up the sides, and you need to figure out a combination that equals 18 because you have 18 people that need seats and no one is going to be left out. You can put tables together or keep them apart. You can put some together and keep others apart, but you're going to put tables together or leave them apart and decide what works. Then you're going to draw and label your plan. Okay? Now, down at the bottom here, I've got 6 tables together, and notice that one side is equal to 6. 1, 2, 3, 4, 5, 6, and my end is 7. And again, 6 plus 1 is 7, so 7 plus 7 is 14. Now, we need 18 seats, so this arrangement isn't going to work because the perimeter is only 14. So I want you to work on this a little bit. Pause the video. Try it with manipulatives and then write down your ideas, what your plan is, okay? So 3rd graders, if you used all 6 tables and you left them separated like this, you would have 4 around each table and you would have 24 seats. That's too many. You would have some empty seats. If you only used 5, that would be 20 seats. You still would have empty seats. But if you only used 4, 4 times 4 is 16, not enough seats. So what can you do, 3rd graders? What if you put one table group together like this? How many go around this table group? 6. 6 plus 4 is 10, plus 4 is 14, plus 4 is 18. So 3rd graders, if you did this and left these 3 tables and didn't use one of them, that arrangement would work. Here's another way that works. I put together and used all 6 tables. And one of the reasons I wanted to do this was to put a few more people together, right? Sometimes when you're in the lunchroom and you have a little bit busier table, there's more people to talk to. So each table, the perimeter is 6. 2 on opposite sides, and then 1 on opposite sides. So that table seats 6, and 6 times 3, or 6 plus 6 plus 6 equals 18. So what happened to the perimeter when we pushed the tables together? We had 4, and we had 4, but we pushed 2 tables together, and now we only have 6 that fit around it. We lost a few spots, right? The perimeter got smaller than when we had the tables separated. So 3rd graders, thank you for doing math with me today. I have a short video, and we're going to do this in May. We're going to learn about famous mathematicians in history. Today, we're going to learn about someone in history whose name was Ada Lovelace. She was a mathematician. She lived in the 1800s in England. She is very important in the history of computers, 3rd graders, and Lovelace's ideas about computing were so far ahead of her time that it nearly took a century for technology to catch up. So we're going to watch this short video, I hope you enjoy it, and I hope you have a good day. Here we go. This is about Ada Lovelace.
Oh, just playing around with these old circuit boards. Yeah? Let me see. Dear Tim and Moby, could you please tell me about Lady Ada Lovelace? From Sean. Sure thing. Augusta Ada King, Countess of Lovelace, is considered by many to have been the first computer programmer. She was born in London in 1815 to Anne Milbank and the poet George Gordon Byron, better known as Lord Byron. A month after her birth, though, Ada's parents separated. Ada stayed with her mother in London while her father left the country. Ada never saw him again. Yeah, it was kind of a rocky situation. Ada's mother wasted no time in taking charge of her daughter's education, though. She'd been interested in mathematics herself, so she strongly encouraged Ada to develop a mathematical mind. She hired private tutors to help teach young Ada, who grew to love working with numbers. Unfortunately, though, Ada was often ill. She suffered from severe headaches and became paralyzed at 14 after contracting the measles. It took almost a full year in bed for her to recover. Well, it helped that she could enjoy homeschool tutoring from some well-known scientists and mathematicians. One of these was Scottish researcher and writer Mary Somerville, who became both a mentor and friend to Lovelace. Somerville encouraged Ada to follow her mathematical and scientific studies and introduced her to various scholars of the day. One of Somerville's friends was mathematician and inventor Charles Babbage. Lovelace became fascinated by Babbage's work, in particular, a machine he'd invented called the difference engine. She paid Babbage a visit in order to see the difference engine in person. It wasn't finished yet, but the machine could automatically calculate mathematical equations in a way that no device at that time could do. She was only a teenager, but Lovelace understood how the difference engine worked and knew it had the potential to be very important. Oh, actually, that was something else. Another of Babbage's ideas was for a device called the analytical engine. It was designed to add, subtract, multiply, and divide numbers, derive square roots, and make comparisons. The machine could do these things by reading instructions on punched cards. You're getting ahead of me, and please don't do that to my boards. Anyway, soon after Lovelace met with Babbage, she married a scientist named William King. King was a nobleman, so he went by a bunch of fancy titles, including Earl of Lovelace. That's how Ada became known as Ada King, the Right Honorable Countess of Lovelace. She had 3 children and quickly went back to her mathematical work. Then, in 1842, another mathematician wrote a detailed description of Charles Babbage's analytical engine in French. By that time, Babbage had grown quite impressed by Lovelace's intellect. He'd even given her an endearing nickname, the Enchantress of Numbers. So he asked her to translate and take notes on the French description of the analytical engine for him. Lovelace worked on this for 9 months, adding many of her own unique insights and calculations. Her notes included a plan for how the engine could calculate a sequence of numbers called the Bernoulli numbers. Today, many historians consider this to have been the first computer program, and Lovelace the first programmer. Computer programs, by the way, are the all-important instructions that computers need to perform any function. Lovelace also predicted that computing machines might one day be used to do things like compose music and create graphics. Yeah, she sure was right about that, and we're living proof. Seriously though, Lovelace was a visionary in many ways. She was only one of a few people in her day who got how these early computers worked, and she was possibly the only one who really appreciated how they might be used. It was pretty impressive, considering she lived at a time when women weren't accepted as scholars, much less mathematicians. In the end, Babbage was never able to fully build either of his early computers. And sadly, Ada's health went downhill not long after she published her work on the analytical engine. It's thought that she suffered from cancer for a number of years. Lovelace died in 1852, about 2 weeks before her 37th birthday. Hey, what did you do with my board? Well, good luck with that.
Have a great day, third graders.